Well, hi, good morning, and thank you so much for joining me in my shop. What you're looking at is my SDR display, and what is happening at 455.3, that's the resonance of the crystal that was in the radio that I've been working on. Hey, I made it work. Yeah, so yesterday in the video I posted today actually, that I did yesterday, I struggled to try to get some kind of response out of a crystal from this radio that would assure me that the crystal was operating. And I was kind of left with the feeling it wasn't operating. And then I brought in some other crystals that I have from, these are CB radio crystals, a little more modern than this guy. And I couldn't get those to go either. Couldn't get any kind of indication as to whether they were working or not. In the evening, I came in here, and after a little bit of experimenting, I managed to get the display that you were looking at a moment ago, showing the resonant point for this crystal. We'll look at it again in a minute. So it turns out, and I may not have this quite right yet, you need to put some kind of load on this arrangement to get the effect, to be able to see the resonant point. The load in this case, oddly enough, is my scope, but my oscilloscope's not even turned on. Here's the probe. So I'm going to experiment with this a little more before we go too far. This is the pickup coil for picking up the signal my SDR is showing you. And I'm just laying this, it's just a clip lead coiled up. I'm just laying it up close to the crystal here, like so. And then some of the signal can make it into my little SDR radio. We can look at it on the display. So once I got this working, I stopped last night, and I was out doing astronomy, in fact, really what I was doing last night. But having got this together, today I want to do some experimenting more with this. Pretty sure I know the exact resonant frequency of the crystal here, or do I? I just want to fool around a bit and become more and more reassured. This is my chance to understand crystals at a higher level than what I've understood it to this point, which is just kind of a basic understanding of how crystals do their trick. To me, it's a stunning thing. I mean, let's face it, this is nothing more than a shaped piece of rock. It's just a modern arrowhead stuck in here. You know, as modern human beings, we like to think we've passed the chipping rock stage to make things, but no, that's exactly what that is. That's a carefully chipped, ground down piece of rock in there. Who says crystals don't have mysterious powers? Okay, by the way, where you see this number here, 455, 300, that's where the red line is. You can barely see it. Maybe you can see it better on your screen right here. So right on top of this. This part is the sweep range of the sweep generator I've got operating, so it's sweeping through the, let's call it resonant or vibratory frequency of the crystal, which is right here. Now, I'm going to start fooling around here, and we'll prove a few things. Maybe I better describe the situation here first. So the crystal is here. The two terminals are here. You see one terminal, I've got nothing connected to it. I've actually got the scope connected to it up here. So there is a connection on the pin here. It basically, this is the sweep signal coming in from my sweep generator. And then this is the scope connection. You can see I've just connected the grounds together. So basically the signal is coming out of the signal generator through the crystal, up through the scope, back down through the ground, and back up to the signal generator. So in other words, the crystal is in series with my oscilloscope, which isn't even switched on. Seems pretty odd to me that I would need to have it this way, but this is where I stopped last night. As soon as I got this, I stopped, because I knew it was a good starting point. So, looking at the display, I guess we can ask ourselves, why is it going up and down like that? I'm trying to stand perfectly still here. I don't know why it's getting stronger and weaker, but so this is the pickup coil. If I move it away, everything goes away. And I'll bring it back. let's say, hold it near some wires here. You cannot see the crystal at this point, but you can see the sweep signal. Same sort of thing here. Now you can see a little bit of the crystal effect because I'm getting physically close to the crystal itself. The crystal, I believe, is that white strip there. I'm not sure. And of course, I put this right up close to it. There we are. Now what I'm interested in is this causing the frequency to change at all? And it doesn't seem to. It seems like it's quite impervious. I think this is why crystals are so fantastic in electronics, because they vibrate at a very, very precise frequency and don't tend to change much, I guess. If you heat it up, cool it down. So now I'm going to put this underneath here where it'll be a little more stable. Okay, I'm going to zoom in on this, on the SDR here, way in, so you get a really good look at it. You can really see the peak is right in here. Okay, now what happens when I disconnect the scope? So when I disconnect the scope, there'll be no complete circuit from the sweep generator. It'll be open-ended, so I do it, of course it's going to stop. Ooh, how do you like that? It's shifted and it's still going. Well, isn't that interesting? I didn't notice this. Well, I didn't do any further experimenting last night. So we shifted the frequency a little bit by attaching the scope lead, which is probably nothing more than a capacitor, just a weird capacitor causing the shift a little bit. So now the frequency is somewhere else. Well, this tells me then for sure, you put this in the radio, and this thing is not necessarily going to be on any particular frequency by itself. It's going to be dependent upon the components around it, which we're going to take a look at in a little bit. What else can cause this thing to go off? Well, what if I, basically, this is kind of weird that it's doing something, because the signal generator connection is just one wire. Is that really the crystal that we're seeing? How could I find this out? We'll just pick this up and move it. Pretty convincing, isn't it? Very surprised. So even just presenting it with an opportunity to resonate, and it's doing it. What if I grab this other terminal here? Well, that's interesting. Went back to where it was. So I mean, it's not surprising if the vibration of, or whatever it is that goes on in these crystals. I don't think the crystal itself is actually vibrating, is it? Is it actually vibrating at 500,000 hertz? Or is it the atomic structure inside the crystal is vibrating? That's more what I think it is. It's not a vibration you could physically measure, I don't think. I don't know. What if I grab the other lead? And it just weakens everything up. Interesting. Okay. What if I stick the ground back on here? This is the ground. Never had the ground on here before. Oh, well, what happened there? It seemed to no, I don't know what I'm doing, so stop this. What if we were to put some kind of variable capacitor across it? And I think I came across one in a box just the other day. Just know what I did with it though. Yeah, I thought I left it right out here for future experimenting. But well, let's try this. We're going to shift now. We're going to change to a different crystal. So now these crystals I have are very high frequency compared to this. This is 500,000 and this crystal is 28 megahertz, 28 million. So you know, so that's like 50 times faster vibration here. My sweep generator won't do the trick on this one. I can only get up to 5 megahertz. These are all, I'm sure these are all CB. Here's one at 10. All CB 10. Why did we have one in here at 10? So sometimes the electronics use frequency multiplier circuits. 10.1. Yeah, I should look through these. Maybe I've got something much lower. 37. That's not a CB frequency either. 27. Now that's a CB frequency. 37.6. It's way above. Well, I don't know where these have all come from. There's one at 23. That's not a CB frequency. So I acquired these without even knowing I'd acquired them. And I've never really looked through them. They just came with a pile of CB related stuff. So okay. So well, we could fool with this 10. The 10 is double 5. Is there any chance? Oh, there's harmonics coming out of my sweep generator. Is there any chance there's harmonics enough to trigger this? I doubt it. Like, I really doubt it. But let's find out. So I'm going to put this crystal away, which appears to be working just fine. And the only way to determine its oscillatory frequency is have it in the circuit that you're interested in. Because the frequency can be shifted slightly by external factors, as we've seen here. No surprise in that. Okay, we'll do the crazy thing. One lead hooked up. Pickup coil over top of it. Just turn it this way so I can see the frequency. 10. 10. Now, there's just a chance there's a harmonic sweeping past it. There's a chance. So we're going to take this first. I'm going to get rid of the zoom here, and you can see the sweep here. I'm going to move it way up to 10. That's not 10. This is 10. Okay, so 10's way down there. Let's put it right in the middle. 10.18 it says. 10 points, so we put 10.18 right in the middle. I brought about here, somewhere in here. Maybe that's it right there. How could it be? So I'm going to pick up the antenna. And move this out of the way. Bring this up. Something that nothing to do with the crystal. Put that there. So there is something funny probably coming from my sweep generator. Let me turn the sweep off. That's the fun about the radio hobby. Lots of stuff to pick up these days. Who knows what it is? Well, it's coming from the sweep generator. It's still sweeping. No, my sweep generator is fixed on one frequency now. I don't know what that is. Dotted line coming along there. Okay, back to doing the experiment. So I'm going to hook up the signal generator to both leads. Let's stick it there. Okay, aside from the weird stuff. Yeah. We're going to switch to a different signal generator, one that I can control a little better. We're going to switch to this old guy here. It's not a sweep generator, but I can manually vary the frequency and have the same effect as with the sweep generator. So turn this guy on. I think I'm going to let him just, no, I'm going to keep going here. Let's keep going. So I will move the generator lead from there. here, this is a strong signal coming out at the gain 456. But I still see the dotted thing on the, yeah, I don't know what that is. Who knows? Weird stuff going on. So now we want to raise this up to 10.18. This is up to 10. Okay, so now I'm going to move. No, I'm going to leave this just like this. There we go. I'm going really slow. I'm going too slow. I'm going to speed it up. 10.8 down here. What I'm looking for is a sudden jump on the screen. Nothing at all. This is kind of the same way I was doing this, and it was failing last time. I just have the signal generator connected directly to the crystal. So now we'll just do excuse me. I'm going to put the crystal in series with my scope again, which we're not looking at and is not switched on. And we'll see if we can find something now. So I'm going to put the marker right on 10.8. Ooh, way over here. Let's go put that in the middle. 10.8. So that's where we're looking, right in here. I'm going to zoom in on that spot. .8 is right here, this red line. But this thing, oh, I see. I think I'm in a ham band, and my my SDR here is switched to upper sideband only. I wonder if I can fix that quickly. I don't know. Yeah, AM, there we are. Okay, there's really no reason to do that. Okay, so 10.8 is right in the middle here. We see a couple things bouncing up, but those are probably just random noise signals. Now I'm going to work the signal generator back down through. Now this is not a sweep generator, right? So this is a different kind of thing here. Okay, let's see. We might see the signal go by on, there it is. So there's the actual signal in the SDR. And we're coming in. Just went right by. I don't see that there's anything going on. Actually, you know what's going on? When you get it right on, it disappears. Oh. Slow down, slow down. You know what's happening? There's a delay in the video image. Very hard to adjust this thing, for this kind of precision. Well, I'm not seeing anything dramatic anyway. I thought when I got it right on, it seemed to suppress it. There, no, yeah, no. I think I'm imagining it. No response whatsoever. That's the answer to that. No response at all. So let's put in this other crystal here. This one, I know I've seen the response on it, so I know it's there. This is at 28 megahertz. So let me raise this up to 28. Oop. 28. Whoa. Wow. Okay, there you are. How's this happening? I'm hitting it with 10.7 and it's going crazy at 28 where it's supposed to be. 28.8. Oh my gosh. What's happening? This is what's happening here? Who's sending out a 28.8 signal like crazy? Look, I'm moving the SDR antenna all over the place. In fact, no antenna on the SDR. Is this some kind of like wild coincidence here? This is, it says 28 point, looks like, can't be sure. 28,685. What's this 20? Oh, is it a harmonic of my signal generator? One of them. I got two of them going, so I'm gonna get rid of the sweep generator here. This one here, is this just what it is? It is not. What is happening? Artifact of the SDR? Just a wild coincidence that it should be just fractions away from the crystal. I've got a bag full of crystals. What are these guys resonating away in here? It's just not possible. This just... They don't have an antenna on the SDR. They have no antenna on the SDR. Well, I think it's going to be a weird SDR thing. If you notice, you'll see out here this shape and this shape, and they're mirror images of each other, and the whole thing, right from here to here. Oh, you know what this is? I know what this is. So I'm up. I'm at the top range of the HF. Range of the SDR, and I think it's getting wonky. Just an SDR nonsense thing. Is that going to ruin this test? So 28.6 is it's way down here. So the answer is no. This won't ruin it as long as I don't look at it. 28.6 way down here. 28,685. 28,685. That's the spot. Way over to the right. I'm going to move this into the middle. I got to set this again. 28,8. 28. 685. 28,685. 28,685. So that's where this thing should be resonating. It's gone on single sideband again, so the red line is on the left side of this gray area. The moment I have the crystal connected to the signal generator driving 11 into it, which has nothing to do with 28.6. Okay, let's raise the signal generator up to 28. Now 28.685. So we're going to watch that screen for something to just come jumping out of there. Oh, we're going way past it already. There's nobody jumping. Nothing happening. Is it because it's way off? It's way off in frequency. Let me zoom this out a little more. Okay, you know, because I'm not using a sweep generator. I have to go fishing for it, and I know from experience last night, you just turn the signal generator frequency just past it at any appreciable rate, and you won't see the response. It is so sharp, so tiny on the band, so to speak. Okay, better put this antenna right back on the thing here, Jim. I didn't have the antenna really in the sensitive spot. Okay, we're going to sweep 685 a little bit here. I don't see a thing happening. Okay, I could be doing something wrong. I'm going to go fishing now. 685. We'll start at 685 and go up. Up. Would you expect this crystal to be off? No. I think what's much more likely is that this is a bogus way of testing it. I don't see a thing. We can employ the oscilloscope here. Yeah, let me stop for a minute. I can drink a little coffee. We'll get the oscilloscope going too, because maybe it's going to give a different response than the SDR. Good. Okay, I had to correct a few things to get this to go, as usual. I didn't have everything right. So one of the things was I had disconnected the SDR antenna and then didn't reconnect it. Okay, so what's happening here now? Let's see if I can make things a little bit simpler. So here's the crystals right there. It's a one of those bigger ones, 28.685, I think is what it's rated at. It says on it. That's my pickup coil there, picking up the signal. But you can see it on the SDR quite clearly. And the scope, you're not aware, let me tune the signal generator, which, by the way, the frequency counter is reading 673, and let's just look on the SDR before I mess this up. I'll just put this right on top. I trust the SDR frequency. Whoops, right there. So looks like it's 68 0.5. So 68, and it's supposed to be, let me just read it to be sure, 685. And this would be in a CV radio, so you'd expect this to be bang on. But according to the SDR, whoops, and one whoop, double whoop, too many whoops. 680. Now watching the, so there's quite a bit of, signal generator's jumping around. Yeah, what happened there? That's not normal in my signal generator. I don't know what happened there. I was just reaching over. I didn't touch anything. More mysteries. Okay, so I'm going to change the frequency here, and what you're going to see, you'll see it move on the SD. You can see it jumping around on the SDR right now. But you watch the oscilloscope, and you'll see the signal drop out. It's not very dramatic. Now if I come across and do this careful, I'm watching the scope now. There, did you see it? Oh, what are all those other little bumps and things? It's interesting. Just before I hit resonance, whatever other RF is in here disappears. The line becomes quite thin, and then this shows up, and you can see. Now, what are we seeing here? Are we seeing the frequency of the? I think we're seeing the frequency being issued by the signal generator, and it's simply not being depleted by passing it through the crystal when the crystal's not oscillating. Is that the right way to put it? It's kind of a nutsy way of putting it. But so, for instance, if I dial this way over, we see about the same signal strength. Let's see, that's coming up to the minus 35 line. And then if I bring it into the tuning spot here. Okay, I'm watching the scope. That's about the maximum there. So it's 680. So it's different each time I do this a little bit, because I think, you know, it's not making its own frequency. It's really affecting the frequency coming out of the signal generator. If I set the signal generator to the stated frequency of 685, my frequency counter is a little high, so I just put it just below, like that. We can see what frequency I've picked here. $691. But you can see this. So that what's this proving? This is proving nothing. Okay, we're gonna go. And I think the next step would be to test all of these. Yeah, I don't think I'm going to do that. I think the next step will be to look carefully at the circuit diagram for the crystal circuit in the radio here and see if we can, I don't know, understand it better. So here's an old schematic, probably one of the original drawn schematics, and here's the area of interest right in here. From this transformer, which represents the input, here's the crystal right there, to this output arrangement here. All this is having a bearing on the crystal operation. In this diagram, they've written the word phasing here. They've left out the word selectivity up here. And this is the switch, the on-off switch that's attached to this control here. Oh no, it's attached to this one. It's attached to the phasing control. Let's look at a bit of a better diagram here. This is just a better drawn version of the same thing. If you notice, there's a complicated input side to this crystal and a complicated output side here too. And I have read what these are doing, but I could never recount it. I'd have to read it another 2 or 3 times, I think. There is an issue with crystals in that the signal can pass through the crystal due to the crystal's capacitance. After all, there's plates close together here, and there's a way of countering that capacitance to stop the signal leakage through it. And you know what, I couldn't tell you for sure what it is. Perhaps it's this variable capacitor here. So this one down here is the phasing control. Again, exactly what effect it's having on the crystal I can't recount. And this one up here is the selectivity control, and they appear to be connected the same way, just in parallel across here, but no, they're a little different. This one's hooked up through here, and they're not quite the same. And then we have this adjustment and this adjustment. These are alignment adjustments. This one and this one are front panel adjustments, and then this is an alignment adjustment here. So there's an awful lot to getting this set up to do what it's supposed to do. Part of what I read was you can this can be too sharp, and so you can control the sharpness with, I believe it's this. Here they've written the word selectivity control, and how it does this, again, I can't really explain. So we could put the crystal in here. If these components are bad, then it's not going to do its thing. If they're out of range, like these are fixed capacitors here, if they've gone out of range, it could be that we'll never get this thing to work the way it's supposed to. This is all contained in a metal box. It's not exactly easy to access either. So what can I do here? Seems the best recommendation for these things is to figure out their resonant spot or vibratory spot while they're in the circuit that they're going to be operated in, because of the influence of all these external components. So I believe this thing is vibrating at 455.3. That's what I think it is from the testing I've done. A little more than what I showed on the video here. I did a little more last night. I got it to respond in a couple of different test approaches and a couple of different ways of measuring the frequency, and SDR and frequency counter. They came back exactly the same with my better frequency counter. 455.3, but you could see how I can move that around by just fiddling around with the layout on my bench. So is that really the crystal frequency? I don't know. This is really, really critical, because they're going to want to align the rest of the radio to the crystal frequency. If I don't get it right, then the radio's not going to perform as well as it could. I don't know if it's just a loss of gain or whether there's more to it. There's probably a little more to it. The other thing about this circuit is that it's really designed to squeeze down the bandwidth down to like 200 or 300 hertz, and then you can listen to the do of Morse code within that tiny bandwidth, but you're not going to listen to anything else. So getting this thing working absolutely perfectly would really exclude it from being used in most cases, because today, if I were using this radio, I'd be listening to somebody talking. Maybe single sideband in the ham world, or just the AM in the broadcast world. And then this, you wouldn't even want this turned on ever. But I have here a radio that looks to be in all original condition. I think the next step would be to try to really conclude whether this is operating or not. And I might be able to do it with the set switched off to start with. Is there any B plus in here? I can't imagine it. I don't really see it. This is a grid. I don't see any kind of voltage being applied to this. So why couldn't I feed a signal in here, energize this primary, maybe with 455.3, and have it come through here? And then I can vary this frequency up and down. I can watch the output over here. And boy, if I really wanted to, I could operate the set and pick off the plate output here to avoid hooking up equipment here for fear of changing things. Let's see, this is a small trimmer, of course. This is another small trimmer. So small capacitances here. And as with all this kind of stuff, when you go to test it, you connect to your test equipment, the circumstances are change, and things don't operate the same. But you can't tell. Every time you connect up, you see what you see, and when you disconnect, it goes back to normal, but you don't know it. So it's pretty easy to falsely test something like this. Very, very easy. And I'm pretty good at doing that kind of stuff, so that's why I'm so cautious on this. So maybe what I'll do is I'll try to set up this non-operating test, and we'll see what we get out of it. And then somewhere later today, I'll reread about how these circuits operate and try to get a better grip on it yet. So let's try that. I'll try pumping in the signal here and picking it up on the plate circuit over here without the radio operating. That sounds like it would be a little bit of fun. Okay, I think I've got things set up. So here's the input going into the essentially going into the primary of the coil, first coil, and then the output. I'm afraid I had to use this clip lead. I'm picking off the grid of tube 5. Not the best. A lot of corrosion on these grid cap things here. There's a problem in itself. See my hand effects going on. Okay, so and I got my sweep generator sweeping just from 450 to 460. So that's what we're looking at on the oscilloscope here. 450 to 460. See nothing. Just before I turned the video on, I was kind of panicking. Oh, there's nothing there. There's nothing there. But maybe the main reason is I haven't plugged the crystal in yet. So we're going to turn the phasing control to 0. That closes the shorting switch. Is there a right way and a wrong way? The NC here was facing forward. Oh, yeah, it would be like this. It would be like so. If anything going on, as I plug it in. Wow, we got a bunch of these ringing effect here. I guess you would call it that. I'm not sure what to call it that. No, the sweep here is the sweep coming from the sweep generator, not coming out of the oscilloscope. That's interesting. Okay, but I've got the phasing switch closed, so in fact this shouldn't show anything. I'm going to turn the selectivity control. Oh, that's interesting. Look what it's doing. Yet again, it is doing the same thing it did before. What did it say in the manual about this? It said when the crystal switch is shorted in shorting position, the selectivity becomes nothing more than another trimmer in the IF and should be tuned for the largest setting. So it would set, and straight up is where, yeah, and it all worked out. Okay, we're going to turn on the crystal now. What will happen? Well, what was that thing in between there? I don't know. We'll set the phasing to, so it just gets bigger all the way. I don't know where to set it. We'll set it, that's the switch opening. We'll set it, around 5. Okay, and now selectivity now is doing something different. It looks the same. Kind of looks the same. You can see something kind of zooming by from right to left and now from left to right. What are we supposed to get on this? Have I done this right? Yeah, it's 455.3 is the resonant point. So the way I have this set up, 455.3 would be roughly in this area here, I think. Let's see, I said 450 here. Let's check. Let me just check here. 448, 449. So this is 449 kilohertz, and this is 460 here. So if I tried to put it right in the middle, the 460 is about 5 higher, so 450 would be 5 lower. So I just turn this up a little wee bit here. Okay, so this should put 456 right in the middle here. I don't know, what do you make of this? Twiddle the controls some more. A bit of dirt in all these switches. Like, what's happening there? Whoops. Well, you can see that versus that versus that. So maybe if the switch isn't going to zero resistance, you get this other shape here, which I can't reproduce now. Maybe I'm cleaning the switch as I'm operating it. That thing. That looks like a little of both. How does this help the radio at all? What would I expect? I would expect there to be low impedance on either side of the vibratory frequency, and then a very high impedance, and so there should be. But I'm reading the output of a transformer. I don't know what this is supposed to look like. Maybe that's normal. Maybe that's all messed up. I got no clue. Certainly when I operate the radio, I didn't fully understand what these controls would do. So I was probably misinterpreting the experience I was having. Maybe the next step is to operate the radio, being a little wiser now, fiddle with the controls and see if it doesn't behave the way you would expect the radio to behave if it's working normally. Maybe it's totally normal. The problem here is that I'm not normal. That's really the issue. Okay, I'm going to stop for a bit and consider operating the radio now. Okay, let's see if the radio still operates after all this monkey business. So I've reconnected the grid connection here, the broken tube. Got the audio connection here. Let's just check it. Something's not right here. Something's not right. Well, this made more of a hum when it's just a small hum. Hey, maybe it's better. Got the antenna connected and switched on. Okay, gain is at 1, RF's at 9, phasing is turned off, CW oscillator off, ABC is off, not that it matters much I don't think in this. Okay, so the name of the game is to try to tune in 9 megahertz on this and pick up the strong station that's almost always there. So 9 megahertz, 9.3 in fact, we would want to around 200. So we'll put this, and I know this is way off, but we'll start with it around 200 and go fishing from there. Okay, I think we're ready. So next step is switch on the 2 heaters. See if the light came on. No hum yet. Unless I turn the level up, way up. Here, just turn it up a little bit. Turn this up a little more. This usually engages a hum. Okay, ready now to bring on the B+. My B+ monitor meter on here. Okay, and here we go. Ooh. Often when I first turn on the high voltage switch on my power supply, there's a release of charge. Here we go. It's very low voltage. And we're hearing stuff. Maybe it's because I got this turned up, didn't I? Help me, what's happening? Okay, I set the volume here so we're not blowing our ears off. What is happening? I don't know exactly. Let me turn the antenna off here. I have no change. Okay, something may not be working right. We need some audio for sure. Yeah. Turn the antenna. Oh yeah. So there's some other hiss in here right now. I don't know what it's from, but some failing component. Let's see if we can find that station. Turn this up. Turn this down. Make sure the RF is up pretty high. Find the station. You would want to go probably up in numbers. That's down. This is up. Any station, anybody, anywhere. I guess I found them there. Let's turn down. Tuning's pretty good now. Let's turn on the ABC and see what happens. Audio. ABC is preventing some distortion. Let's leave it on. So I've got the master volume control over here that I can turn up and down. You can't see my hand, so you might wonder what's going on. I don't want to generate an incorrect mystery here. I'm going to turn it up a little bit, and then we're going to fool with the selectivity control first with this switched off. This is off. The selectivity control is another trimmer in the IF, and you just want to maximize it. Let's see if it really works that way.
Y con esto quiero decir lo siguiente: cuando una persona En el año, digamos, 50, en el periodo ese 56, 57, 58, pre-régimen castrista, compraba con un
Well,
peso. Y
it's very
recordemos que en
subtle.
aquella época el peso...
Okay, I got my hand on the control, so I have a little better idea what's happening. But I could hear a slight improvement when the selectivity was set in the middle. Nothing very dramatic there. So now we'll turn on the crystal. When we do, the bandwidth should shrink, and we should lose treble. Something like that should happen.
Y con esos $100 tú te montabas un avión y podías venir para los Estados Unidos. Se ha disminuido y en estos momentos lo que tú comprabas en aquella época con un peso, ahora ese peso vale 3 centavos. Es decir, es lo que tú puedes comprar con 3 centavos. Es decir, hay una pérdida dramática.
Put this on 5. The selectivity should...
riqueza que tiene esa pérdida de riqueza es la que ha ayudado a financiar al régimen por estos largos años.
De hecho, tú comentabas de la palabra, yo creo, de la riqueza y hablabas de las clases productoras. Es que en realidad en Cuba se ha estado viviendo, incluso hasta el presente, con, digamos, la infraestructura que se heredó. Es claro que en Cuba, por ejemplo, Fidel Castro hizo...
Judging the operation of this using an AM signal is a little tough. You could be removing one sideband and the other sideband. You might not even really hear a difference in the sound. What we really need is a station with heterodyne in one sideband. And there's a fat chance finding that. But we'll look. There's a couple more stations right around here. Let's see if I can find one with heterodyne. But like I said, not very likely at all. We need to get on a crowded CW band.
Entonces tenemos por un lado de todo el campo socialista esa cifra
Isn't there another one?
And so much for each one of us. We are spoiled children to the degree that we don't even recognize all the blessings. But we know, Father, they come from you.
Yeah, that sounds better. Get my sarcasm?
I ask for your... Make us a courageous people. May we go out, go forth with love.
Well, I would say this is not functioning as a crystal
Father,
filter.
I pray for
That's how I would... You know, I could cause a heterodyne here. I could cause a heterodyne.
Father, for the hostages. We've been
I think I'm going to leave that for another occasion here.
They were brutally murdered just recently.
Let's just listen to this radio for a little bit because, wow, once again, despite all my effort.
I pray for them that your arms of comfort and peace will be...
You could hear the AVC bring the level up a moment after I left that station. Let's try that again.
The hostages of war and the hostages
Tune
that we
away
have
and you
here
should
in our own
hear
country,
the hiss come
held
afterwards.
in prison.
Yeah, it's just very quick, but it's there.
120, 30.
Very quiet radio otherwise. Even with the AVC switched on. There's nobody else. Tuning's very good.
There's a big difference between revivals and the word revive.
Okay, let's see if we can get this guy a little stronger. I don't think this is doing the right thing. I think this is acting as a trimmer in the IF.
who were there. How long will you keep us in suspense? If you are the Messiah, tell us plainly. Yeshua answered, I did tell you, but you do not believe. The works I do in my Father's name testify about me, but you do not believe. You are not my sheep. My sheep listen to my voice. I know them, and they follow me. I give them eternal life, and they shall never perish.
Eternal life. I could fix radios for eternity. That's a long, long time. This radio's working really, really well. I mean, there's nothing here to pick up, so I don't think this is an indication of something wrong with it.
El mismo estado de cosas. 500
They refuse to take responsibility
Hey, here's
for
a
the
heterodyne.
things that they have done. And then accuse others of political stunts. And I'm speaking of the 13 Gold Star families who they shunned. It seems Democrats have...
That's a weird sound.
Star families.
I'm listening to the whoop, whoop, whoop. I'm not listening to what she's saying.
Cowards are known for running and hiding, and they have to lie to hide their dishonor. They run away from what they have done.
Okay, so the whoop is gone now.
Not because they're ashamed of it, because they don't want you to know about it.
Turn on. Well, that sounds very much like a crystal filter working there. Tiny, tiny bandwidth. Let's turn things up. Turn things up here.
Which Romney had to go after. And him. Swalwell is an idiot and a gassy coward.
He is, eh?
National security. Why is he still in office? Biden cartel compromised, selling America out to China, to Russia, to Ukraine. Literally. Testosterone-free tampon too. Praises China. He is one scary coward of a man. Did you see him literally run from the media when he was asked about the death of the American Hamas killed?
Okay, I think that's enough fiddling there.
With his hands full of food.
Get this propaganda off out of my ears as quickly as possible. Yeah, it's pretty weird. I'm sure that's an American broadcast there. What do they think they're doing? My God. Building an audience, that's what they're doing. They want an audience, doesn't matter, television, radio, whatever. I don't care, frankly, about my audience. I shouldn't put it that way. I don't care about the size of my audience. The size of my crowd, I don't care about it. What I care about is fixing these things up and having some fun doing it and sharing that with anybody who's interested. Why are those people on the radio saying that stuff? Why? Oh my God. Boy, if you're my age, you probably have the feeling that everything is going to hell in a handbasket. And some time ago, I showed something to do with chaos. I'm going to show it again because I think it's very important to understand this. That the human civilization is a chaotic thing. I believe. It's certainly hard to not believe it. So here's how chaos works. So chaotic systems fall into sort of semi-stable conditions for a while, and then they move out of the semi-stable into very unstable, and then they eventually fall into another semi-stable condition. So this is where we've been since the Second World War, more or less like this. There we are. Whoops, going like that. Okay. And now what's happening is things are starting to whack out. They're starting to go very chaotic. This is how it feels, anyway. I don't know what the truth is. And eventually this chaotic stuff will find another place to kind of settle down. We could be talking about world trade patterns. We could be talking about who knows what. Chaotic systems do this kind of thing. And it'll sit there for some length of time before it starts wandering off again. I've run out of ink. I've worn my pen out doing that. So there you are. That's a diagram of what's happening in the world right there. Yeah, there's a whole mathematics around this. Mathematics of chaos is a fairly recent thing. I think it was explored in the 70s because people thought chaotic systems, how can you apply mathematics to it? You know, I got to remember to turn this guy off before I forget and do something bad. So that's where we are. Welcome to the world of chaos. Thanks a lot for watching the video, and tomorrow I think I will start with trying to inject signals into the antenna, sweep signals. I'll try to figure something out here, and once again we'll try and sweep the radio. I got much better knowledge now about everything. Maybe I can get a better result out of sweeping it. At this point, I think these controls are not behaving the way they should, but I'm not sure, because that last little test sounded to me like a crystal filter, because I'm familiar with what they sound like. Okay, see you on the next video. Have a great day.